phase is feature extraction. So what feature extraction is doing, you are taking the raw data, then you pre-process it, and then you make it compact. So compact representation of say raw data is called as feature extraction. So as I said earlier, say this is say 100 by 100 image, then you represent this maybe by a vector of size say 1 row and 10 columns. Okay, so 1 by 10. So that is called as feature extraction. So your features are available here. So once features are available, you choose model for learning. So this is the key thing. What you will do here is a key thing. So deciding a model depends on what problem you are tackling with. Say whether you want to do classification, you want to do clustering, or you want to do regression. So this will define what kind of model you will use. Even within classification, you have to decide so many things before you do any processing of features. So whole this thing is a key factor in machine learning. So this is a key thing. So our focus should be here. Then once you do fix up the model, you do the training, everything is done, then your model is ready. So here your model is ready for usage. Okay, so here onwards, you will take this model and then you will go to the testing phase. So what testing phase is doing here, you will take data from real world, that is the data which is not known to you earlier. A new data will come to you and you need to process it, or you need to classify it or cluster it, whatever it is. So depending on the situation, you get some new data here. Again, you will do the same pre-processing steps. You will extract features over here, and those features then will go to a classification box, or it will be the input to the given model. This is a trained model. So this is a trained model. This model will come here. Okay, so once you take new input from real environment, that will be processed and feature extracted from that will be given to this new model. New model will do the post processing and it will take some decision on it. Okay, so it will do classification, or it will estimate if it is a regression problem, and then you will take a final call, final decision. So you just remember these two things, training and testing. So data used during training cycle is called as training data, and data used during test cycle, it is called as test data. So more on this we will see in subsequent chapters. Right now you just remember there are two phases, main phase, two main phases, that is training phase and test phase. Now there are many approaches for machine learning. So whatever we will be doing in this course is basically the classical approach. Okay, so this is called as classical approach, or the approach which is in existence for quite a long time. So if you see the history of Bayes, the Bayes approach or Bayes theorem, I think came in 16th century. So it's quite old that way. So those days computers were not available. Still, the genius people could do this work. Now, next point is artificial neural network. This is nowadays very, very popular. Okay, so that is another approach in this field. So it came in 1947 or so. Then you say fuzzy logic is another way of doing machine learning. It came in 1962. Then came rough set, I think in 1983 or 6. Okay, and then this is that way based on Darwin's principle genetic algorithm. So this is also there. Basically, it is used for optimization problem. Then you have combination of all these things. Okay, so combination of all these approaches is called as soft computing. So you may have an algorithm with say genetic plus rough set, or fuzzy logic with genetics, or artificial neural with fuzzy logic. So any combination is possible. So all those things will come under the heading of soft computing. So these are, however, the basic 5 things currently available, okay, in machine learning. And as I said, this particular course will focus on Bayesian approach. So we will see quickly what these approaches are, and then from next class onwards, we will start our actual business. The classical approach came in 1763. Uh, it was proposed by Bayes, and it was not in this form that we are learning now, but it was for predicting in terms of probability. Okay, so basic principle used was statistical property of data. So classical approach is basically this thing. It uses statistical property of data. Hence, extracting underlying probability model is the base for such methods. Now, the Bayes formula is very simple. This is the thing whole this subject will depend on. Now, if you try to understand what is the posterior, what is the likelihood, what is prior, then you have to understand the basics of probability. Now the equation is posterior equal to likelihood into prior divided by evidence. So what do you mean by likelihood? What do you mean by prior? What is evidence? And what is posterior? So this we have to see in detail. Now you must be aware of this equation maybe in 12th. See, if I say probability of A given B, so this is conditional probability. Probability A given B is equal to probability B given A into probability of A divided by probability of B. I hope you know this formula. Okay, so this is coming from the derivation is very simple. It will be, you can derive easily from joint probability of A and B. Okay, if you want, I can just do that. Probability of A, say, and B is equal to probability of A given B into probability of B. This is also equal to probability of B given A into probability of A. So you can equate these two equations. This is a joint probability of A and B, and this is the you can say conditional probability of A given B, and this is B given A. Okay, so if you equate these two equations, you can equate this, so that you can simplify like this. Okay, that is the simple derivation. Now here we just modify this simple equation in this form. So we call this as posterior, we call this as likelihood, we call this as prior, and we call this as evidence. Okay, so details you are going to see, but right now just try to remember this, that this is already known to you, and we are going to take help of all these formulae. Now we can take a simple example of this Bayesian approach. Let us say that there is a set of features. So this is a set. Assume that we have extracted only one dimension of some object. So this is only 1D data. So this is sample number 1. So I can write instead of this like this. So this is sample 1, sample 2, and so on. I can go up to sample, say, n. So these individual elements of this set are feature vectors. Now, if this is a feature vector, then this should look, say, like this. Say x1 should look like this. So x1 is equal to some x1, x2, and so on up to maybe d dimension. Okay. Now, in this simple problem, these other things are absent. I will say x1 is a one-dimensional feature. So x1 is a small x1. Okay, that's it. That means suppose I am measuring length of some object, then it will be just one number. I have so many objects with me. I have so many objects, and then if I measure height of everybody and put it into a set, then it will be this kind of a set. Okay, then I will call it is sample space. So this is my sample space. Okay, so what is this? This is feature. Feature is a compact representation of data. Okay, say maybe some image is given to you, and this is some object in that, and you have measured somehow height of this object. Okay, this height is written over here. Then this is height of some second object, this is height of some third object, and so on. So I keep on measuring heights of different objects, and they are listed like this. So once I list every interested object, then it becomes sample space. Is that fine? Okay, so there are two classes in this problem. So this feature list is divided actually into two groups, say class 1 and say class 2. Maybe this is feature of, say, an eraser, and this is class 2 belongs to, say, maybe duster. Okay, so this is duster, and maybe this is some rubbers, erasers. Okay, so there are 8 elements in class 1, there are 7 elements in class 2. So what is sample size? Sample size is of 15, right? Then what I can do is I can just plot this information available to me for the elements in the sample space. So there are objects with 0.1, 0.2, 0.3, 0.4 heights, and I can just count how many they are and divide by total number of samples. So that will be, maybe this is 0.4 here, this is 0.1, this is 0.2, maybe this is 0.15. So total of these individual probabilities is 1. Okay, say for example 0.1, how many times it is appearing? Say 0.1 is appearing, say 1, 2, 3, 4, 5, 6, and 7. 7 times 0.5 is appearing in my problem. So 7 divided by 15 is the probability of 0.1. So probability of 0.1 is 7 divided by 15. So that I am indicating here. Okay. Then I count how many times 0.2 is appearing. So 0.2 is appearing, say 1, 2, 2 times. So this particular point is, say, 2 divided by 15. So this will be 2 divided by 15. Okay, so like that I can plot all this distribution of probability. So this graph will be probability distribution graph. Now here my basic purpose of showing you all this is this equation. What this equation is, so if I concentrate on this one, this is called as posterior. Here what I am predicting is, given some input feature x, suppose I say current measurement just 1 second, I have a call. Hello. Okay, so this is, say, current measurement from the environment is, say, height is equal to, suppose, point, let us say 4. Now this is called as x.4. Now question is, what is class of this object? I don't know what is this, whether this is a rubber or this is a dust. So this question I have to answer, and my measurement is 0.4. Given to me is all this data. So this data, we are calling it as training data. I hope you got the concept of training data. So what is training data? Training data is the data which is priorly known to you for training. Okay, so this x is equal to 0.4, and question is, what is the probability of being duster or being rubber? So probability of class 1, given x is equal to 0.4, probability of class 2 given x is equal to 0.4. So if I answer these two things, if I find out somehow these two probabilities, then what probability wins for which class, that will be my prediction. Say for example, here probability for class 1 given x is equal to 0.4 is suppose 0.3, and probability of say class 2 given x is equal to 0.4 is 0.7. Remember, sum of these two will be always equal to 1. So probability of class 1 is less than probability of class 2. That's why I will declare that given input x is equal to 0.4 probably belongs to class 2. So I will say this is some duster. Okay, so that will be my decision. So you can imagine the situation. There is some image and this is your system which is designed by you. So this image will go to this, and this system will decide the winner. So output is class 1 or class 2. So input image is processed and you are using Bayes equation, say this Bayes equation, and you are predicting the classes. Now how you predict? So here the prediction called as posterior. So probability of given class. So instead of class, we are now writing omega. So if I say omega 1, it is class 1. And input is always capital X or small x. So whenever I write capital X, remember that this is a vector. So if I write probability of omega 1 given small x, that means this feature is one dimensional. Okay, so when I write capital X, it is at least two dimensional. Okay, so if it is multi-dimensional, I will be using X. If it is single dimensional, I will be using small x. So this is the posterior or prediction. Now you will see this term probability of x, say given omega suppose 1, and there will be also probability of x given omega 2. Now this term is called as likelihood. Now if you remember from your probability knowledge that the condition here is given thing is omega 1 and here given condition is omega 2. So what basically this probability is talking about, it is talking about the domain of class 1 and domain of class 2. That means when I say probability of x given omega 1, it is talking about some domain omega 1. Within that domain, what is chance that I will see x is equal to say 0.4. So it clearly means I am talking about, say, this is omega 1. So all these samples belong to omega 1. This is omega 2. Then all these samples belong to omega 2. So when I say probability of x given omega 1, then I am searching for some value of x. Suppose I say here value of x is suppose 0.4. Then I am searching for 0.4 in this list. You will see there is no 0.4 in this list. So my count is 0. So 0 divided by 8. So 0 divided by 8. So probability of x given omega 1 where x is equal to 0.4 is 0. Now suppose I write probability of x is equal to 0.1 given omega 1. So in this case, I will just concentrate on omega 1. So I am not seeing what is happening in omega 2. So I am just interested in omega 1. So that's why it is called as likelihood. Within that domain, what is happening? So within that domain, how many times 0.1 appears? So I just count 1, 2, 3, 4, 5, 6 times. So 6 times is 0.1 appearing in omega 1 out of how many samples? 8 samples. Okay. Now I hope you can understand what is this. If I write probability of x is equal to 0.1 given omega 2, then what is my purpose here is concentrate on omega 2 and see what is chance of 0.1 appearing in omega 2. So just go to omega 2, this second list, and check how many times 0.1 is appearing. So it is just appearing one time. So one time divided by how many samples? So out of 7 samples, only one sample belongs to 0.1. So this is called as likelihood. Okay, so this is likelihood. Okay. Then the prior knowledge is about the classes. So there are 8 samples of class 1. So omega 1 samples are 8, omega 2 samples are 7. Okay. So in total there are 15 samples. So probability of omega 1 is 8 by 15. Probability of omega 2 is 7 by 15. Okay. So this is called as prior knowledge of the classes. So this is prior. Within my domain, how many times omega 1 appears, how many times omega 2 appears. So this information is prior. So we have now seen 3 or 4 terms. One is posterior. Posterior stands for the prediction. Okay, posterior stands for prediction. Likelihood stands for probabilities within the domain. Prior stands for the prior information about the classes. And evidence stands for how many times this 0.4 appears. Say how many times the given measurement 0.4 appears in my problem domain, irrespective of classes. Okay, so that is called as evidence. So if you go with this problem further, you can find out this is the likelihood 6 times. Say I think I have solved this with the help of x is equal to 0.1. You can try afterwards. If x is equal to 0.1, then what is the likelihood? So you count how many times 0.1 is appearing. So in omega 1, so 1, 2, 3, 4, 5, 6. So 6 out of 8. So there are 8 samples here and 7 samples here. So 6 by 8 is 0.75. So this is the likelihood of 0.1 in omega 1. Then what is chance of omega 1 itself? So this is prior knowledge. So 8 samples out of total 15 samples are omega 1 samples. So this is talking about class 1. Okay. So 8 divided by 15 is 0.53. Then we want to find out the evidence. Say probability of x is equal to 0.1. Considering all the classes we have. So here we have 2 classes. So it is 6 by 8. So this is probability of x is equal to 0.1 given omega 1 into probability of omega 1 plus probability of x is equal to 0.1 given omega 2 into probability of omega 2. So this will be probability of x is equal to 0.1. So how this is obtained, that we will see again in detail. So this is called as sum rule. Okay, so we will see this in detail. So it will be 0.46. So put into this equation all the information we have. So for x is equal to 0.1, we predict that it belongs to omega 1 to the extent of probability 0.86. Now, if you solve same thing for omega 2, you will get probability for omega 2. So, without calculation, I can just say it is 1 minus 0.86. Okay. Because I know the sum of these two must be equal to 1. So, like this, we take Bayesian decisions based on these probabilities. So don't worry about this. I will be taking this thing from scratch. So even if you don't recall what these probabilities are and what these relative probabilities are, we will start with basics in subsequent classes. But I just wanted to show you how this decision making process will work. Thing is, you will find out probabilities of say omega 1 given x, omega 2 given x, and so on up to omega say k given x. So k stands for number of classes. How many objects your computer want to learn? How many suppose letters you want to learn? Say letters are say in English A to Z 26 letters. Then you can have small a to small z again 26. Then numbers 0 to 9, say they are 10. Then you can add some symbols like dollars, hash, and so on. So if you see your keyboard, then maybe you will end up with some 70, 75 say important say characters. And if you are trying to make a system which will be recognizing the printed text from an image, then you must understand all these classes. So you can imagine that I should learn 70 to 75 classes if I want to convert given image into text file. Okay, so that application you can keep in mind. So we will see this in subsequent class. I will just go through very quickly now through this artificial neural network which came in say 47 or 48 or so. So basic biological neuron was studied first and then inspired from that in 1943, not 48, it is 1943. McCulloch and Pitts proposed the first mathematical model of neurons. So McCulloch found that a priori of Plato is encoded in the complicated neural structure of brain, and then in 49 Habe adopted or added adaptive mechanism to this proposed mechanism. So this Habe could add this Aristotle's mechanism of adaptability in neuron in 49. Okay, it took 6 years, 6 years to modify basic neuron structure to make it adaptive. Okay, then you will find in 51, after 2 years, some hardware realization was possible due to this fellow Minsky. And this Minsky is the fellow who actually stopped the research of neural networks in 60s or 70s. So around 20 to 30 years, there was no research, maybe from 1960s to say 80s. Okay, so there is a big gap of 25 years. No research could happen due to this fellow's research publication that neural network cannot handle non-linear data. So what is all this we will see later. Okay, so but remember that Minsky is a fellow who find out who could find out the drawback of artificial neural network in the initial stage, and this initial stage drawback was removed in 80s. 80s to 90s is the golden period of neural network. First, you can say golden period, where all the earlier problems were solved. And then came, I think, in 2008 or 9, maybe to 2014 or so, and maybe till today, the second phase of golden period of neural network. Okay, this is now called as deep learning, and this is known as ANN era. Okay, relation is simple, but there are some differences that we will see later on. Now, how neural network works? It's a simple single cell of your brain. This is the nucleus, and you will see that the input side of the cell. So if I draw a cell here, there are so many inputs coming to this cell. They are called as dendrites. So these inputs are called as dendrites, or input connections are called as dendrites. So here you will get inputs from previous or set of neurons earlier to this, and then output is produced on axon. So how it is produced? So all these neurons will work on electrochemical signals. So they will be receiving actually impulses like this, and they will be aggregated over a period of time here. So they will be added together, and once it is beyond certain, this sum is beyond certain limit, then there will be signal coming out of this. Okay, so this subsequent axon is fired and it is connected to another set of neurons ahead. So this is how your brain works. So we will see details of this in next course in final year of BTech final year, called as artificial neural network. So we will see there more details about this. But time being, just understand, based on this, we have another set of tools for machine learning. So human brain consists of, this is just information, 10 to the power 11 neurons, and each neuron is having 10,000 connections. So you can imagine maybe 10 to the power, say 4 here, and 10 to the power 4 here, and 10 to the power 11 here. So maybe 10 to the power 15, 14 to 15 connections do exist in your brain. So it's a huge circuit. Okay, this is a huge circuit. So this was the first model. This is just information that how it looks. So there is a input. This is called as feature vector. So these are weights of the connection, and they will be aggregated here, or say in this form called a summation, and it will be compared with some threshold, and you will produce output 1 if it is more than the threshold, or 0 when it is less than the threshold. So this is the base of neural network. Based on this, you can say if output is +1, it is class 1, that is object 1. If it is 0, then it is class 2. Okay, say +1 represents, say, pen object, and maybe output 0 represents duster. So you can learn two objects using a simple neuron. So simple neuron can do, say, object recognition of two objects. If you want more objects to be recognized, then you have to increase number of neurons, and then your circuit becomes complicated. So question is how to train such kind of circuit, that we will see later on. So there are many neural network circuits available. say single layer perceptron, multi-layer associative memories, then self-organizing networks. If you take deep networks, then you have autoencoders, then deep belief networks, say generative and say GANs, generative adversarial networks, then convolutional networks, recurrent networks, LSTMs, and GRUs, and so on. So there's a huge list now. So this is all new. Okay, here this is the classical ANN. Mind you, but you can understand all these new methods provided you understand the basics. Okay, so that one must understand. Then came the fuzzy logic. This has some other meaning. So we will cover up, I think, in next class. So we have to stop here. So any difficulty you can ask till now? I will be putting these slides on your classroom so you can go back and see those things and study regularly. I will be taking your quizzes regularly. So I will not ask that today there will be quiz. You have to attend all the classes properly, and quiz will appear at the end of any class. Okay, so be ready, and it will be depending on what we have seen earlier. So quiz will not contain anything which is new. It is just based on previous classes. So if you are following all the classes properly and doing regular study, you will be uh, getting proper marks. So that is how it will work. So any doubt you can ask.